Welcome to the walkthrough for Assignment 4. The objectives of this assignment are to learn how to synchronize gazes by concurrent beings via a reader's writer lock, implemented using a Java stamped lock, and a fair semaphore, implemented using your solution to Assignment 3B. Videos describing Java stamped locks appear in my earlier YouTube channel playlists. I recommend you watch these videos to ensure you understand how Java stamped locks work. Naturally, this topic is also covered in the videos from this semester's class as well. The fair semaphore and Java stamped lock are used to enhance the Java Executor Completion Service Framework implementation of the Palantiri Simulator app from Assignment 3A. Assignment 4 focuses on the Palantiri Manager, which is used to restrict the number of beings from Middle-earth who can concurrently gaze into a fixed number of Palantiri. The Palantiri Simulator app is packaged as a project using the latest version of Android Studio. As always, this app is written both in Kotlin and Java and demonstrates many interesting Android capabilities. For the purposes of Assignment 4, however, you only need to be aware of the following three directories: the stamped lock fair semaphore directory, which contains the skeletons you need to fill in, as we talk about shortly, the unit test directory, and the Android instrumentation test. You'll need to integrate your enhanced solution for the completion service folder from Assignment 3A into the latest and greatest completion service skeleton and use it as the implementation of the being manager for Assignment 4A. Make sure to address all of my comments from both Assignment 3A and Assignment 3B into your Assignment 4 solution. In particular, you have to make sure that your fair semaphore implementation works correctly, or this particular assignment will go poorly. As always, to compile the code, you'll need to use the Android Studio project. I think you probably know how to do this by now. Let's talk about the to-do task you'll have to fill in. You'll have to focus on the stamped lock fair semaphore folder, which contains the stamped lock fair semaphore manager.java class, where you'll have to implement the Palantiri manager using a fair semaphore, a stamped lock, and a hash map. Notice that this time you'll not be using a concurrent hash map, but just a regular non-synchronized hash map, because the stamped lock will be what's responsible for synchronizing access to the hash map. You'll also need to either implement the fair semaphore MO or fair semaphore CO files, and that's, of course, if you're an undergrad, you're using the built-in Java monitor object solution, whereas if you're a grad student, you'll be using the condition object and reentrant lock. As always, you need to pass the unit tests, and you have to pass the instrumentation tests. Grad students who implement this program need to provide some additional tasks by using Java functional programming features, such as method references, lambda expressions, and/or sequential streams, in several places in the simple semaphore manager.java file, the stamped lock simple semaphore manager.java file. Undergrads are welcome to implement these features, but it's not required. The skeleton code for this assignment is available in my GitHub account. As always, once you've completed your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. It should be pretty clear what you need to do. This part of the assignment is designed to deepen your understanding of synchronizing multi-threaded programs using Java stamped locks, which are more powerful, more complex, and sometimes more efficient compared with spin locks and the reentrant locks that we've covered in previous assignments. Now that we've discussed the specification for Assignment 4, let's go ahead and walk through the skeletons. If you drill down in the Simulator, Managers, Palantiri, Stamped Lock Fair Semaphore folder, you'll see there's only a single file, Stamped Lock Fair Semaphore Manager. The other files that are important here actually are going to be used from the Assignment 3B Concurrent Map Fair Semaphore folder, namely the Fair Semaphore and either Fair Semaphore CO or Fair Semaphore MO files, depending on which version you're implementing. So those will have to be implemented correctly from Assignment 3B, which I assume you'll be in good position to do based on all the feedback and walkthroughs I've done. So let's go ahead and open up the stamped lock fair semaphore manager.java file. As you can see, as always, this extends Palantiri Manager. That's nothing new. We define an available Palantiri field, which is a fair semaphore. We define an mPalantiri map, which is a map that maps Palantir to Boolean. You need to go ahead and add in the Java stamped lock synchronizer that'll be used to protect the M palantir map state. Then down here, you'll have to implement the reset method, which is going to look quite a bit like the build model method. And so what's going to happen here in build model is you're going to have to go ahead and initialize the M palantir map. You should be able to do something pretty much like what you did in assignment 3B for that. You'll have to implement the appropriate semaphore, either using fair semaphore CO if you're a grad student or fair semaphore MO if you're an undergrad. And then finally, you have to go ahead and initialize the stamp block. That's more or less the same thing you'll have to do in reset. Okay, so now let's talk about acquire. So first and foremost, this particular acquire is going to have to protect the state of the M palantir map explicitly, because we're no longer using a concurrent hash map. So as a result, you have to do explicit synchronization. The first thing you'll do, of course, is you'll have to come in and acquire the semaphore, which will use your fair semaphore implementation from assignment 3B. Make sure that you implement this properly. If an exception is thrown, you want to catch the interrupted exception and then rethrow the cancellation exception. That should look more or less identical to what's in assignment 3B. Now let's talk about what we're going to have to do to implement the acquire method using the stamped lock. The way this is going to work is you're going to go ahead first and acquire the lock for reading. So you'll acquire in read mode. And then you'll essentially iterate through the palantir map. And there's a couple of different ways to do this. One way to do it is to use literally the iterator mechanism that's built into Java. And if you do that, you'll get an iterator to the map, and then you go ahead and iterate through it element by element. And you'll be iterating through it using the entry set mechanism that it provides. And so what'll happen here is you iterate through it, you'll be checking to see whether or not the value of the entry set items is true, meaning it's available. Keep in mind the read lock will be held at this point. When you discover that you find an available palantir whose get value comes back as true, what you're then going to try to do is you're going to try to upgrade to a write lock. And this is what's called the conditional write lock semantics. So you'll be using the stamped lock upgrade feature, which is illustrated in the link that's shown down here. If you go to the documentation for Java stamp lock, it'll show you some examples of how to do the conditional write lock upgrade. So you'll try to get a write lock. If you're lucky and you succeed in getting the write lock in a non-blocking manner, then at that point you'll have a write lock, and then you can go ahead and, with the write lock held, set that value to be false and go ahead and return the item that's the key corresponding to that value that you just set to false, and then make sure that you unlock the lock, unlock the stamp lock. That's the happy path. That's if you're lucky. If you're not lucky, you'll find out that somebody already owns the write lock, because all these things can be happening concurrently. So in that case, what you're going to have to do is you're going to have to release the read lock and then acquire a write lock. And when you acquire the write lock, this time you're going to have to actually block. So you're going to have to use the blocking acquire method. When that returns, now you have a write lock, and what you're going to do is reset yourself to start back over at the beginning of the iteration using the iterator, for example, and then search from the beginning to the end again, trying this once again. You will eventually succeed, but it may take more than one try. So that's the easy way to do it. That's the way to do it using the built-in Java iterator features. You could also use a loop if you wanted to, or you could be really super duper clever and use a loop in conjunction with Java streams, where you would go ahead and convert the entry set into a stream, filter out anything in that stream that is true, whose value is true, then go ahead and use the find first method, which is a terminal operation on the stream, to get the first available item that is not in use, and then go ahead and check to see if that's present, because it might not be. So you get an optional back from find first. So that's a little bit more sophisticated. That's really kind of the cool Java streams, functional programming way of doing things. And I recommend you try that if you can. Grad students should really try that, because that's part of the functional programming aspects for grad students. But that's basically the logic. And so when you're done, you'll of course release the lock, and then you'll return. Make sure, of course, that you keep the semaphore acquired. You don't want to be releasing the semaphore in the acquire method. The release method is much, much simpler than the acquire method. All you need to do there is come in, check to make sure that the Palantir is not null. Then you acquire the lock for exclusive access, in other words, a write lock. And you do the normal trick of doing a put or replace into the map, seeing what the return value is, and if it comes back with what you expect, going ahead and releasing the semaphore, and then finally unlocking the lock. And make sure that you always do these locks and unlocks in the right try finally context, as we've talked about many times before. So that basically is all there is to this assignment. The real tricky part here is the acquire method, and that's going to take you thinking through what it means to implement something that uses the conditional write lock with the lock upgrade mechanism. Now that we've described the specification for assignment 4 and walked through the skeletons, it's time to show how to run the unit tests. As usual, we'll come in here and click run the tests in the simulator. And as you can see, we have a lot of tests now. These are all cumulative. We have 166 tests or so, give or take. And if everything goes well and you've got your implementation done correctly for all the previous assignments, as well as assignment 4, everything should end up being nice and green at the end. If you take a close look at these tests, you'll see that we have essentially black box tests that just make sure that they get the right answer, as well as very, very sophisticated white box tests that try to peek under the skirts of the abstraction to see what it looks like and how it works under the hood. And in all the different cases, if your program is working correctly and you want to get a full score, then all the tests should pass and should all be green. As you can see here, all of my tests pass, which perhaps is no surprise because I wrote the assignment and also helped with the writing of the tests. But your test should also do the same thing. So if you have any problems whatsoever with this assignment, don't hesitate to ask. As you'll also undoubtedly notice, we keep improving the tests from previous assignments. So occasionally you'll have something that will have passed with a previous test suite and now will fail because we've added new tests. So if you have that kind of problem and you're curious about what went wrong, let me know. But again, you can take a look. There's a lot of tests here. So it may take a little while to run. Depending on your processor speed, some of the tests might time out. If that happens, let me know, and I'll be happy to try running your code on my machine to see whether or not it's just a processor issue or whether there's something wrong with your code or the tests.